to all of you. Plus center of gravity. Just reason brief point is called center of gravity of the body in which the total weight of the body concentrate. Two points from center of gravity we have seen. That's the center of gravity and its position depends on the and mass distribution of the object. Center of gravity is towards the heavier part of the object, and you know that it is for geometrical lines at the geometrical center of the regular body, and mostly center of gravity depends upon the mass distribution shape of the object. Deforming a body, center of gravity will change. The position of center of gravity will change. And total moment of force about center of gravity is zero. Okay. Once again, total moment of force about center of gravity of any object is zero, because the body balances at center of gravity. Or you can say the body is in equilibrium at center of gravity, so how must be zero. This also we have seen that the center of gravity lies at the geometrical center of regular bodies, and for irregular object we can find the position of center of gravity with the use of line. The next topic is uniform circular motion. Uniform, हिंदी meaning of uniform मतलब एक समान. Okay, it means the speed remains uniform and circular. Circular is circular path. Motion, the object will move. Right? The three words, uniform, circular, motion. Uniform means the speed remains constant at any point. And circular means the object will move in circular path. This is the meaning of uniform circular motion. A body is in motion with uniform speed in a circular path. You can say as uniform circular motion. Right? Two things to be considered. You can see bracket rate. Speed should be constant, and the second motion should be in circular orbit. Two parts. The meaning of uniform circular motion. Point number, and speed should be constant. And number two, the object must move in circular path. Right? You can see an item. Suppose an object is moving in clockwise direction. You can see in the diagram few arrows are shown. Suppose you take a stone and manually spin and pull it overhead. Okay, just move it. Move in a circle. And if you release the string from your hand, in which direction the object tends to move, these are shown by the arrows. The object, as soon as you release the object will move tangentially along the tangent shown by the arrows. Okay? So at any point, the object will move in a circular motion, but as you release the object will start moving tangentially. Right? Let me discuss this point. I'm taking an object moving in a circular path. The circle object is at the position so by the diagonal, and the object is moving in anti-clockwise direction. Okay? So as you release, this is the radius. As you release the object will move tangentially shown by the arrow. Look at that. Okay. So at point, bring it at point A, two arrows indicating the direction of velocity at point A moving right. If I take another point, suppose a point here, you can see I'm putting it on point B. At position B, the object will move tangentially. Right. Arrow is given at point B. The direction of velocity at point B you can see by the black arrow. Then I take another point, suppose here, green point. So if you draw a tangent, the direction of velocity, point C, green, shown by the arrow. The hope is here. An object in a particular path, a different point, the direction of velocity is different. Okay. But the velocity and the velocity which is known as speed at any point, suppose the p points shown in the diagram ABC will be constant. The magnitude of velocity that is point speed will remain constant, but the direction of velocity will change at its point. I hope this is clear. Honorable Mason, I would like to ask to turn down. Yes, sir. Okay, thank you. So, all of you clear? That what is the meaning of uniform scalar motion? Object will move in a circular path with constant velocity. Second point, at constant speed. And second, we have seen that the velocity is constant or changing. Isa? Velocity is changing. Okay. So see the if a particle is moving, the second line is black. If a particle is moving in a circular path, the direct velocity changes at every point. And how to find direction velocity? Given by the red line. Tangent gives the direction of velocity. Okay. And if the velocity is changing, that is accelerated motion. Right? Is it clear? If I ask that the body moving in uniform circular motion, its motion is accelerated motion. Why? Anybody like to say the answer? Once again, I repeat the question. Body is
also change at every point.
Okay. The direction of velocity is changing at every point. So you can say that the velocity is changing. Okay. What is the accelerated motion? All of you know. Accelerated motion तब होता है velocity change. Velocity change नहीं होगा तो accelerated motion नहीं होगा. So we find that motion of moving in a circular path at any point velocity change. Velocity changing is the will change or the direction will change or both. Value, magnitude or direction. Here at the direction of the velocity change at points means and if the velocity it means the motion is accelerated motion. I hope this is clear to all of you. So let us see the difference uniform circular motion and uniform linear motion. Let's see the column. Uniform. In both cases, uniform word is used. Uniform circular motion and uniform linear motion. Uniform here, the speed is same. Right? So what is the difference in uniform? You can see on the table. Uniform linear motion, uniform circular motion. First, you can see the difference. The uniform linear motion, velocity remains constant. But in circular motion, velocity changes and we have seen that the object is moving in a circular path and at every point the direction of velocity is changing. So we can say that the velocity is changing at every point. Second difference, and all of you know if there is no change in velocity, there will be no acceleration. And if there is change in velocity, there will be acceleration. Okay, so you can see. First one says that velocity remains constant, so there is no acceleration. Uniform circular motion, you can see that velocity changing and velocity there is acceleration. So these are two main differences. Again, what is written? See, in both cases, speed remains same because both are uniform motion. In any kind of uniform motion, the speed will remain constant. Anyone? Any problem? This topic? Yes.
No, sir.
Okay, Anushka Paul. Is it clear?
Yes, sir.
Okay, thank you. Let us see the next slide. Centripetal force. Very important topic for the examination point of view. Centripetal force. So one question to you all. Already you have read it. When the concept of torque is coming to our mind, at what kind of the object torque is used?
The circular.
Yes, rotational motion. Whenever the centripetal force will be used, centripetal means that object must be in circular motion. Yes. अगर किसी और मोशन है तो सेंट्रीपिटल का okay. Whenever the word can see centripetal force, it means that the object is in circular motion. Okay? So centripetal force you can see it is in circular motion by a force towards the center of the circular path is known as centripetal force. Anybody would like to say what is Newton's second law?
Therefore, equals to mass into acceleration.
Good. So whenever the question is asked what is Newton's second law, the definition is rate of change momentum is directly proportional to force. This is the statement you write. And from there we derive F equal to m. Okay? So ask about whenever the question is asked what is Newton's second law, don't say F equal to ma. F equal to ma is derived, okay, formula derived from Newton's second law. Okay? So don't confuse. Okay, anyhow. So from Newton's second law, you know F equal to ma. Right? So let me to increase the size of the font. F equal to ma. Right? You know A is the acceleration. A is the acceleration, m is the mass. Right now we have seen that if an object is in circular motion, then it is the example of accelerated motion. It means there is some acceleration. Yeah, there is some acceleration. Okay? Means there is some acceleration means A is not equal to 0. Now you see that formula F equal to ma. If there is some acceleration, can you say there is some force? If you put the
Yes.
value. Yes. Yes. Because m cannot be 0. किसी भी ऑब्जेक्ट का मास 0 नहीं होता है at any situation. So mass never be 0 and there is some acceleration. It means that if an object is moving in a circular path, a force is acting. Okay, a force is acting on the object. Okay, and that force is called centripetal force. What we know, any object moving in a circular path, first point we got that at any point the velocity is changing. And if there is change in velocity, there is acceleration. And if there is acceleration, a force must act on the object. And that force is called centripetal force. So what is the importance of this centripetal force? It is always directed towards the center of the circular path. Okay? Any force acting towards the center of the circular path is the centripetal force. Right? All of you listen this important line that if an object is moving in a circular path, a force must act towards the center. That force may be friction, that force may be tension, that force may be gravitational force, that force may be a push, that force may be a pull, anything else. Right? So any force that you see acting towards the center of the circular path, you just name that force as centripetal force. Okay? Is it clear to all of you? कोई भी फोर्स जो सेंटर की ओर लगेगा उसी को सेंट्रिपिटल फोर्स बता देना है, नथिंग एल्स. Okay? Is it clear?
Yes.
Pushkar Kumar?
Yes, sir.
Okay. So all of you understand what is centripetal force. Always remember the direction of centripetal force is always towards the center of the circular path. this year in model exam class 10, I've given one question to state the direction of centripetal force and centrifugal force. So you will not believe that more than 50% of the student unable to write what the direction of centripetal force. Somebody is writing towards tangent, somebody is writing outside. Okay, somebody is writing along the circle. Okay, somebody is writing if an object is moving on a frictional path. Variety of wrong answers. So all of you be very clear that centripetal force always act towards the center of the circular path. Okay, we'll take a 5 minutes break right now and then we'll join once again at 10:16. Now it is 10:11. Okay, all that back I think. So find centripetal force. Now, if I ask what is the unit of centripetal force, what will you say? Anyone? Unit of
J.
facts, what is the unit of force?
Newton.
For J, Newton or Joule. Sorry, Newton.
So why Joule? Joule is the unit of what? And energy. Okay, this force, so unit is Newton. Any force, unit is Newton. Whether it is frictional force, whether it is centripetal force, whether it is tensional force. Now I told you the concept of centripetal force will come to your mind if the object is in circular motion first. And second, the force acting towards the center is the centripetal. जो भी कोई force जो center की ओर लग रहा है, that is the centripetal force. अब centripetal force ढूंढते नहीं रहना है. Any force that is acting towards the center is the centripetal force. And with all of you have learned the contact forces and non-contact forces. Please name some contact and non-contact forces. I'm writing one, push. Pull. Anything else?
Sir, tension, friction.
Tension, friction. Anything else? Contact, non-contact forces.
Collision.
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 Normal reaction.
Normal reaction. Next. Anything?
Gravity.
Gravitational force. Magnetic force. Electric force. Yeah. So any force out of this, and if you know more forces, any force which is acting towards the center is the source of centripetal force. Okay. Now, all of you see this diagram. The object is moving in a circular path here. The object is moving in a circular path. So centripetal force acts on the moving object, not any other object, right? The object which is revolving, which is circulating, on that object only centripetal force will act. When the object is at A, the direction of centripetal force will be towards center. I'm putting the arrow, please see, in the red. Okay? The centripetal force will be towards the center. When the object is at C, the centripetal force will act towards the center. You can see the arrow. ठीक है, सेंटीमीटर फोर्स हमेशा ऑब्जेक्ट आने से कोई मतलब नहीं है. The direction of centripetal force will be always towards the center. Now, question to all of you: do you think that the direction of centripetal force remains same every time? No.
Sir.
So you can see every time the direction of centripetal force is changing, but it is always positive. Good. On to slide. See the rate, what is written. Centripetal force provided by some force. Okay, some force means push, pull, friction, gravitational force, anything. Some force acting on the object towards the center of the circular path. You see any force acting towards the center of the circular path, that force will provide the centripetal force. Example you can see. Number 1. Electrons move round a nucleus. Right? So which force is acting on the electron? You know the force between the nucleus and the electron. Right? That is, nucleus is positively charged, electron is negatively charged. So force that is called electric force or electrostatic force between electron and nucleus. Okay, so that force provides the centripetal force. Which force? Electrostatic force of attraction between the electron and nucleus provides the centripetal force to the electrons so that the electrons revolve around the nucleus. Second example you can see. A stone tied at the end of string and wheel in a circular path. Which force is responsible for centripetal force here? The answer is given. Tension along the string. If there is no tension, the object will not move. The stone will not move in a circular path. Okay? There must be some tension along the string. So here the tension provides the centripetal force. Okay? Is it clear to all of you?
There is the gravitational force on us an example of centripetal force.
Yes. Possible.
The gravitational force on us.
Yes. Are you moving in a circular path?
No, sir, because sir, I'm not going because of low mass. But still the force directed towards the center.
No. First thing all of you remember, object must move in a circular path. Okay? If all of you be very clear, if the object is moving in a circular path, there must be centripetal force. And that force you have to identify. Okay?
Okay, sir.
Yes.
So then we could not experience that we are moving, but we are moving, so we are also having centripetal force.
Actually, we are any object on the surface of the earth is a single entity, right? You, myself, any other object, any other person attached with the earth. Okay, all the objects you can consider a single entity. and the Earth is revolving around the Earth. Right? The Earth is moving almost in circular path around the Earth. So, which force is responsible to move the Earth around the Sun? Answer please.
Centripetal force.
So the gravitational force of the sun.
Gravitational force of the Sun. So here, the Earth is revolving around the Sun because of the gravitational force. So here the centripetal force is because of the gravitational force, or you can say the gravitational force provides the centripetal force to the Earth. Okay, so first thing you have to see the object is moving in a circular path or not. If yes, there must be centripetal force. There must be a force acting towards the center, and that force is the centripetal force. That's all.
And so the rotation of the Earth.
That is not the circular path. Your question is itself answered. You have said the Earth is rotating. Okay, that is not the
The Earth is rotating, but it makes us move in a circular path around the center of the Earth.
No. Rotational motion is different from circular motion. The Earth is rotating. Rotational motion, okay, centripetal force may not be required. Circular motion, like the total Earth is moving around the Sun, that is in circular motion. Rotational motion is different from the circular motion. Okay, so first you have to see the object is moving in circular motion or not. Okay, we'll see two more examples, then the thing will be clear. Okay, going to the next slide. Here you can see third example, motion of a vehicle on a sharp turn. If there is no friction between the road and the tire, and if the vehicle or your cycle also, if you take a sharp turn, moving in circular path, what will happen? You will skip outside. If there is no friction, है ना? बरसात के दिन में होता है ना? You are moving with a very high speed in a turn, then you will skip out. And so in this case, friction between the road and the tire provides the centripetal force, so that the vehicle will move in a sharp turn, or it will move in a circular path. So third example, the motion of the vehicle on a sharp turn. Centripetal force, okay, the friction, or you can say the friction provides the centripetal force here. Fourth example, you can see a planet moves around the sun. Already we have explained it. The Earth is revolving around the sun, not that planet revolving around the sun. The gravitational force of between the sun and the planet provides centripetal force. And the last example, motion of moon around the Earth. Again, the force, gravitational force between the Earth and the moon provides a centripetal force. Okay. Here these three examples. Anyone having any doubt? Response? Anyone?
Yes, sir.
Okay. Is it clear, centripetal force?
Yes, sir.
Should I go to the next topic?
Yes, sir.
Go to the next topic. So the force depends on these three factors. And this derivation of formula you do in class 11. Okay. You may, the question may raise in your mind that why the centripetal force acts towards the center. All these things will be explained in class 11. Okay, this formula will also be derived in class 11. ठीक है, सेंट्रीपिटल फोर्स का डायरेक्ट सेंटर की ओर ही क्यों होता है? That we'll discuss in class 11 because some new topic in mathematics is required to solve that. Okay, anyhow, here the centripetal force depends upon the mass of the object, the velocity of the object, and the radius of the circular path. The formula of centripetal force is tan v square by r. Okay.
Yes, sir.
Okay, next topic is centrifugal force. Centrifugal force, you remember, it is the fictitious force or imaginary force, virtual force or imaginary force. So see, an object is rotating. An object in a rotating frame experience an outward force known as centrifugal force. Try to understand with an example. This is a sharp turn. A sharp road turn. And the block indicates the car moving in this turn. It means the car moving in a circular path. Which force will act on the car? Answer is the car is moving in a circular path. Which force will act? Huh?
Fiction.
Centripetal force, I told you earlier, friction will be there, enthalpy will be there.
Centripetal force.
Okay, the right friction force and the centripetal force. Okay. The car experience centripetal force towards the center of the circular path. That is the centripetal force acting in the car. Now you have noticed that suppose you are sitting the back chair, okay, back seat. The dot is your position. As soon as the car will turn in a circular path, all of us notice that it tends to push outward. Have you noticed? Will push to the other side, like this, given the arrow, red arrow. Have you noticed it?
Yes, sir.
When the car will turn, or bus will turn in a circular path, it tends to move towards the window, outer side, right? So that force is the centrifugal force, right? The force is the centrifugal force, imaginary force. Nobody is pushing you. Nobody is applying a force to you, but an imaginary force will act on you in the outward direction. That force is the centrifugal force.
Then why not
Car is,
here?
what is inertia motion? If it is inertia, you should move in the direction of motion. Okay. If it is inertia, then you should move in the direction of the car. But you are moving in outward direction. Okay. So that imaginary force acting on you is the centrifugal force. Okay. Is it clear?
But in
So this is
sir, but inertia, if we assume in the diagram that at that point we are at inertia, then the car moves towards it, it rotates, it goes in circular motion in the left path, but we are still at the same point, so we will automatically be pushed the opposite in the opposite direction in the right.
what you inertia of rest or inertia of motion?
Inertia of rest.
Not that rest, the object is not at rest. Okay, the object you are moving with the car. The passenger or the person sitting behind is moving with the car. Right? So if it is the inertia of motion, the object must move when it is left. Okay, it should move in the direction of the motion. ठीक है, अगर आदमी को बाहर फेंक दिया जाए, then the person will move in the direction of motion of the car. Okay, that is the inertia of motion. Here the concept is not at all inertia. Okay.
So will the magnitude of centripetal force be equal to centrifugal force?
Not necessarily, not always. Okay, sometimes yes, but not always. They are not action reaction forces. Okay. Sometimes they are equal, sometimes they may not be equal. Because centripetal force is in the car, on the car, but the centrifugal force is acting on the person, to different objects. Okay. So there are so many points on centrifugal force. We'll discuss one after one. You can see around the slide, but tomorrow. Now it is 10:36. We'll discuss.
Sir, can you show the center of gravitation of irregular objects?
Okay, sorry, I will not to other section. Let's go over there. Next tomorrow I'll show you. Okay. Okay then. Thank you to all of you. Have a good day.
Thank you.